There's a compound sitting in your grocery store right now, tucked away in the produce section, that researchers have spent the last 3 decades quietly obsessing over. It's not a peptide. It's not a steroid. It's not some black market bodybuilding powder with a name you can barely pronounce. It comes from broccoli sprouts, and it's called sulforaphane. Now, before you roll your eyes and think, great, another vegetable is going to save my life, stick with me here, because the research behind this stuff is genuinely wild, and it's the kind of science that rarely makes it into mainstream health conversations because, frankly, a compound derived from a vegetable doesn't have a marketing budget the way a supplement company's flagship product does. Sulforaphane is what's called an isothiocyanate, and it's produced when you damage the cell walls of broccoli, cauliflower, kale, or Brussels sprouts, whether that's through chewing, chopping, or blending. When you break those cells open, an enzyme called myrosinase gets released and it converts a precursor compound called glucoraphanin into sulforaphane. Broccoli sprouts, specifically the 3 to 4 day old sprouts, contain anywhere from 20 to 50 times more glucoraphanin than the mature broccoli head you'd buy at the store. That's not a small difference, that's an entire order of magnitude, which is why so much of the research you'll see coming out of institutions like Johns Hopkins has focused specifically on sprout extracts rather than just eating a side of broccoli with dinner. So what does this compound actually do once it's in your body? This is where things get interesting, because sulforaphane doesn't work the way most supplements work. It's not delivering a nutrient your body's deficient in, and it's not blocking a receptor the way a pharmaceutical might. Instead, it activates something called the NRF2 pathway, which is essentially your body's master regulator of antioxidant and detoxification genes. Think of NRF2 as a switch that's sitting inside nearly every cell in your body. And under normal conditions, it's held in check by a protein called KEAP1. Sulforaphane binds to KEAP1, which releases NRF2, allowing it to travel into the nucleus of the cell and start turning on genes that produce your body's own antioxidant enzymes. Things like glutathione, superoxide dismutase, and natph-quinone oxidoreductase. This matters because your body's internal antioxidant systems are dramatically more powerful than anything you could get from an external antioxidant like vitamin C or vitamin E. Those vitamins can neutralize one free radical and then they're spent. But when you upregulate your endogenous antioxidant enzymes through something like the NRF2 pathway, you're creating catalysts, molecules that can neutralize thousands of free radicals over and over again without being used up. This is a fundamentally different, and arguably far more efficient, strategy for combating oxidative stress, which is one of the core drivers of aging, chronic disease, and cellular damage. Researchers have been documenting this pathway since the mid-1990s, but it's really in the last 10 to 15 years that the clinical research has exploded, looking at everything from cancer prevention to metabolic health to brain function. And here's the part that I think is genuinely underappreciated. Because sulforaphane works through this hormetic mechanism, meaning it applies a small, manageable stress to your cells that triggers a protective overcorrection. It's playing in the same biological sandbox as things like exercise and fasting. Your body doesn't distinguish perfectly between different sources of mild cellular stress. A hard workout, a period of caloric restriction, cold exposure, and compounds like sulforaphane all seem to activate overlapping defensive and repair pathways. This is why you'll increasingly see sulforaphane discussed alongside topics like autophagy and metabolic flexibility, because it's not acting like an isolated nutrient, it's acting like a signal that tells your cells to ramp up their maintenance and defense systems. Over the course of this video, I want to walk you through 4 major areas where the research on sulforaphane has produced some genuinely striking findings. First, we'll get into the cancer and angiogenesis research, which is where sulforaphane first captured scientific attention back in the early 1990s, and where some of the most compelling laboratory and epidemiological data exists. Second, we'll talk about gut health, inflammation, and immune function, because it turns out this compound has a fascinating relationship with your microbiome that most people have never heard of. Third, we'll dig into longevity, fasting, and metabolism, connecting sulforaphane's mechanisms to the broader science of cellular aging and metabolic health, including some surprising research on blood sugar regulation. And throughout all of this, I want to be upfront with you. This is not a magic powder. There is no single compound that replaces a comprehensive approach to health. And anyone telling you that a supplement can substitute for medical treatment when you actually need it is not someone you should trust. What I am telling you is that the research on this particular plant compound is far more substantial and far more mechanistically interesting than most of what gets hyped in the supplement industry. And it deserves a real, honest look. So let's get into exactly what the science says, starting with the area that put sulforaphane on the map in the first place, its relationship with cancer biology and the way tumors grow. The story of sulforaphane's connection to cancer research actually starts with an observation that had puzzled epidemiologists for decades. Populations that eat more cruciferous vegetables, that's broccoli, cauliflower, cabbage, kale, and their relatives, consistently show lower rates of several types of cancer, including bladder, breast, lung, prostate, and colorectal cancer, across dozens of large-scale population studies conducted in the US, Europe, and Asia. For a long time, nobody could pin down exactly why cruciferous vegetables specifically seemed to carry this protective association, since plenty of other vegetables didn't show nearly the same strength of correlation. That mystery is largely what led researchers at Johns Hopkins, particularly Dr. Paul Talalay's lab, to isolate and study sulforaphane specifically back in the early 1990s. What they found was that sulforaphane operates through several distinct anti-cancer mechanisms simultaneously, which is part of why it's generated so much research interest. Because most single compounds only hit one pathway. The first mechanism involves what's called phase 2 detoxification enzymes. Your liver processes potential carcinogens, whether they come from cooked meat, environmental pollutants, or cigarette smoke, in 2 phases. Phase 1 enzymes can actually activate certain carcinogens, making them more reactive and potentially more dangerous, while phase 2 enzymes neutralize and help excrete them safely. Sulforaphane has been shown in laboratory studies to boost phase 2 enzyme activity substantially, which effectively helps your body clear out potentially harmful compounds before they can do damage to your DNA. This isn't a theoretical mechanism either. There are human trials, including one notable study conducted in Qidong, China, a region with historically high rates of liver cancer due to aflatoxin exposure in the food supply, where participants who drank a beverage containing broccoli sprout extract showed a measurably higher excretion of aflatoxin-related compounds compared to a placebo group, suggesting the detoxification pathway was actively working in real human bodies, not just in a petri dish. The second major mechanism, and this is where the angiogenesis angle comes in, involves sulforaphane's effect on how tumors develop their blood supply. Angiogenesis is simply the process of new blood vessel formation, and it's something your body needs for wound healing and normal growth, but it's also something that tumors hijack in order to grow beyond a microscopic size. A tumor without a blood supply is limited to about the size of a pinhead because it can't get enough oxygen and nutrients to grow further, but once it manages to signal for new blood vessels to form, a process largely driven by a protein called vascular endothelial growth factor, or VEGF, it can grow rapidly and eventually spread. Laboratory research, including studies published in journals like Molecular Nutrition and Food Research, has found that sulforaphane appears to suppress the signaling pathways that promote this kind of abnormal blood vessel formation, essentially working to starve developing tumors of the resources they need to expand. Researchers have also observed that sulforaphane seems to interfere with histone deacetylase enzymes, often abbreviated as HDAC, which play a role in regulating whether certain genes get turned on or off. Some cancer cells rely on abnormal HDAC activity to silence tumor suppressor genes, the genes that would normally tell a damaged cell to stop dividing or to self-destruct, through a process called apoptosis. By inhibiting HDAC activity, sulforaphane appears to help restore the expression of these protective genes in laboratory models, essentially helping cells regain their ability to police themselves. There's also compelling research specifically on cancer stem cells, which are a small subpopulation of cells within tumors that are thought to be particularly resistant to chemotherapy and radiation, and are believed to be responsible for cancer recurrence after treatment. A study out of the University of Michigan found that sulforaphane reduced the population of these treatment-resistant cells in laboratory breast cancer models, which is a particularly exciting area of ongoing research because standard treatments often struggle specifically against this resistant subpopulation. Now, I want to be really clear about something here, because this is where a lot of health content online goes off the rails. None of this means sulforaphane treats or cures cancer, and none of this should ever be interpreted as a reason to delay or replace conventional medical treatment. What this research does support is a role for sulforaphane and cruciferous vegetables more broadly in cancer prevention and risk reduction, which is a meaningfully different claim and one that's backed by a genuinely impressive convergence of epidemiological data, mechanistic laboratory research, and even some human clinical trials. The scientific consensus, reflected in guidance from organizations like the American Institute for Cancer Research, is that regular consumption of cruciferous vegetables is one of several dietary factors associated with lower cancer risk. And sulforaphane appears to be one of the primary bioactive compounds responsible for that association. This is exactly the kind of finding that gets buried under flashier, less substantiated claims in the wellness industry. But when you actually look at the underlying research, the multi-pathway mechanism here, hitting detoxification, angiogenesis, gene expression, and even resistant cancer stem cells is genuinely more sophisticated than what most single-target pharmaceutical compounds are able to achieve, and it's exactly why researchers keep coming back to this compound decade after decade. Now, let's shift over to gut health, inflammation, and immune function, because this is an area where the research has really accelerated over the past decade, as scientists have gotten better tools for actually studying the microbiome. And sulforaphane's relationship with your gut turns out to be a two-way street that's more complex than most people realize. Here's the first surprising piece. Your gut bacteria actually play a role in how much sulforaphane you absorb in the first place. Remember that conversion process I mentioned earlier, where glucoraphanin gets converted into active sulforaphane by the myrosinase enzyme? Well, if the myrosinase enzyme in the plant itself has been destroyed, which happens when broccoli is overcooked, certain gut bacteria can actually perform a similar conversion themselves, acting as a backup system. This means your individual microbiome composition can influence how effectively you convert and absorb this compound, which is part of why researchers have observed fairly significant individual variation in sulforaphane bioavailability between different people eating identical amounts of broccoli. But it goes the other direction too, because sulforaphane also appears to actively shape your gut environment once it's absorbed. Research published in journals focused on gut. Microbiology has found that sulforaphane and related isothiocyanates can help support the growth of beneficial bacterial populations, while making the gut environment less hospitable. For certain less favorable bacterial strains, this matters enormously for your overall inflammation levels, because your gut lining and the trillions of bacteria living there are in constant communication with your immune system. And roughly 70% of your entire immune system is actually housed in gut-associated lymphoid tissue. When the gut barrier becomes compromised, a condition often referred to informally as increased intestinal permeability, bacterial fragments called lipopolysaccharides can leak into the bloodstream, triggering a low-grade chronic inflammatory response throughout the body. This kind of chronic, low-level inflammation is increasingly recognized by researchers as a common thread running through an enormous range of modern health issues, from cardiovascular disease to metabolic dysfunction to neurodegenerative conditions, which is why so much current research attention has shifted toward compounds that can help support gut barrier integrity. Sulforaphane appears to help on this front through multiple angles. First, through that NRF2 activation we talked about earlier, which helps reduce oxidative stress specifically within intestinal cells, supporting the integrity of the tight junctions that hold your gut lining together. Second, through direct anti-inflammatory signaling. Laboratory and animal studies have consistently shown that sulforaphane reduces the activity of a protein complex called NF-κB, which is essentially the master switch that turns on the production of inflammatory cytokines like TNF-alpha and interleukin-6. When NF-κB activity is chronically elevated, whether due to poor diet, chronic stress, excess body fat, or gut dysbiosis, your body ends up in a persistent low-grade inflammatory state. And dialing that pathway down is one of the more consistently reproduced findings across sulforaphane research, showing up in studies on everything from arthritis models to inflammatory bowel conditions. There's also fascinating research specifically on ulcerative colitis and general gut inflammation models, where sulforaphane supplementation reduced inflammatory markers and helped preserve the mucus layer that protects your intestinal lining from irritation and bacterial invasion. On the immune function side specifically, researchers have found that sulforaphane appears to modulate immune cell activity in ways that seem to help balance an overactive immune response without broadly suppressing immune function, the way some pharmaceutical anti-inflammatories do. This distinction matters a lot, because you don't actually want a compound that just shuts down your immune system across the board that would leave you more vulnerable to actual infections. Instead, the research suggests sulforaphane works more like a rheostat than an off switch, helping to calm excessive chronic inflammatory signaling while still preserving your immune system's ability to respond appropriately when you're actually exposed to a pathogen. There's also some genuinely interesting research on respiratory health specifically, with studies out of institutions including Johns Hopkins, finding that broccoli sprout extract supplementation increased antioxidant enzyme activity in the airways of study participants and appeared to help reduce inflammatory response to air pollution exposure, which is particularly relevant if you live in an urban area with significant air quality concerns. None of this means sulforaphane is a replacement for actual immune-supporting basics like adequate sleep, regular movement, and a genuinely balanced diet. Those fundamentals still matter more than any single compound ever will. But what the gut and immune research does show is a consistent, mechanistically coherent picture. This is a compound that seems to support the underlying infrastructure of your gut barrier and your inflammatory regulation systems, rather than just masking symptoms. And that kind of foundational support is exactly what tends to compound into meaningful long-term health benefits rather than short-term superficial effects. Let's bring this all together now and talk about longevity, fasting, and metabolism, because this is really where all the previous mechanisms start to connect into a bigger picture about aging and long-term health. Remember that hormetic mechanism we talked about at the beginning, where sulforaphane applies a small, manageable stress to your cells that triggers an outsized protective response? This is the exact same biological principle that underlies the health benefits associated with intermittent fasting, caloric restriction and regular exercise, and it's why researchers studying longevity have become increasingly interested in how these different interventions might overlap or even amplify each other. When you fast, your cells experience a temporary state of nutrient scarcity, and in response they activate a cellular cleanup process called autophagy, which is essentially your body's internal recycling system, breaking down damaged proteins and dysfunctional cell components and repurposing the materials for new, healthy cellular structures. This process tends to decline naturally as we age, and its decline is thought to be one of the contributing factors behind the accumulation of cellular damage that characterizes aging tissue. Interestingly, some research has found that sulforaphane may help support autophagic processes as well, working through overlapping signaling pathways involving AMPK, an enzyme that acts as your cell's energy sensor and gets activated during states of energy scarcity, whether that's from fasting or from certain compounds that mimic that cellular stress signal. AMPK activation is a big deal in longevity research generally because it's one of the primary mechanisms behind the benefits associated with caloric restriction, and it's also the same pathway that the diabetes medication metformin works through, which is part of why metformin has generated so much interest in longevity science circles beyond just its glucose-lowering effects. This connects directly to sulforaphane's surprisingly robust research on metabolic health and blood sugar regulation. A study published in Science Translational Medicine, conducted by researchers at Lund University and Gothenburg University in Sweden, found that concentrated broccoli sprout extract significantly reduced fasting blood glucose and improved hemoglobin A1C levels in obese patients with dysregulated type 2 diabetes, with effects that were particularly pronounced in patients who had higher initial blood sugar levels. What made this study especially notable was that the researchers used genomic data to specifically select sulforaphane as a candidate compound after screening thousands of potential options for their ability to counteract the gene expression patterns associated with excess glucose production in the liver, and the results held up in an actual randomized, placebo-controlled human trial rather than just laboratory models. This matters enormously in the context of longevity, because chronically elevated blood sugar and insulin resistance are considered major accelerants of the aging process, contributing to everything from cardiovascular disease to cognitive decline to the kind of chronic low-grade inflammation we discussed earlier. So, a compound that appears to genuinely help regulate glucose metabolism through a novel mechanism is a significant finding, not an incremental one. There's also emerging research on sulforaphane's relationship with mitochondrial function, which is essentially the energy-producing machinery within your cells. As we age, mitochondrial efficiency tends to decline, and this decline is strongly associated with the fatigue, reduced exercise capacity, and metabolic sluggishness that many people experience as they get older. Some laboratory research suggests that NRF2 activation, again coming back to that same central pathway, may help support mitochondrial biogenesis, essentially encouraging your cells to produce new, healthy mitochondria, which could theoretically help counteract some of this age-related decline, though this specific area of research is still earlier stage compared to the cancer and metabolic research we discussed. There's also research on brain health worth mentioning briefly here, since cognitive longevity is such a major concern for people as they age. Studies have found that sulforaphane can cross the blood-brain barrier and has shown neuroprotective effects in laboratory and animal models relevant to conditions involving oxidative stress and neuroinflammation, likely again through that same NRF2 antioxidant pathway. Though human clinical research in this specific area is still developing, and it's too early to draw firm conclusions about cognitive protection in people. So how does all of this translate into something practical? If you're looking to actually incorporate this into your routine, the research suggests that 3 to 4 day old broccoli sprouts are the most concentrated whole food source, though they can be an acquired taste and aren't always convenient to source consistently. Standardized broccoli sprout extract supplements are widely available, and many are tested to provide a specific, consistent amount of active sulforaphane or its stable precursor, glucoraphanin, which addresses that bioavailability variability issue we discussed earlier. If you're eating broccoli or other cruciferous vegetables in whole food form, lightly steaming rather than boiling helps preserve more of the myrosinase enzyme activity. And pairing cooked cruciferous vegetables with a raw source like mustard seed powder can help restore some conversion capacity if the enzyme has been damaged by heat. As with any compound, more isn't automatically better. And extremely high doses used in research settings don't necessarily translate to something you should be replicating on your own without guidance, especially if you're on medications, since sulforaphane can influence drug-metabolizing enzymes in the liver. If you're pregnant, have a thyroid condition, or are on prescription medications, it's genuinely worth checking with your doctor before adding a concentrated extract, since cruciferous vegetables in general can interact with thyroid function at very high intakes. What makes sulforaphane such a compelling subject for a deep dive like this one isn't that it's a miracle powder that outperforms everything else on the market. It's that it represents a genuinely well-researched example of how a single plant compound can influence multiple interconnected systems: cellular defense, gut health, inflammation, metabolism, and cellular aging through one elegant, central mechanism. That kind of multi-system coherence is rare, and it's exactly why this unassuming little sprout keeps showing up across such a wide range of serious scientific research, decade after decade, without ever needing a flashy marketing campaign to earn its place in the conversation.